क्यों बैठ रहे हो? यहाँ बैठो. Arush is asking you to join. Deep. Hi, Arush. Okay. Ultimash is saying join from there. तो बेटा अभी problem आएगा अगर join. Okay. I can't see Sarita ma'am.
Hey, Mumtaz, I'm here.
Hi, I can hear you now. Good morning. Great timing. So, how are you doing? It's such a pleasure to hear you early in the morning.
Hi.
Is there a network issue at your end, Sarita?
Yeah, some bit. Is it not good? I mean, you can see the video. Can you hear me?
I can hear you. A little bit with resonations, but I can hear you. Yes, we can see you as well. Good morning. It's always a pleasure to see such a beautiful smiling face. Always. Right. So, just to tell you, there is a huge turnout. Don't look at the 16 there because there are people in auditoriums in schools who are sitting together, 300 at a place, and all such like that numbers. So, there is a great turnout. We're very happy about it. So, good morning and welcome to this beautiful mystery that's going to be unfolding very, very shortly up, around us in the universe. I was going to say up above in the sky, and then I just realized that's such a crazy thing to say because it's all around us, the universe, right? I started, thanks to astronomy, I've started looking at the universe so very differently now, and it gives me great honor and pleasure to invite you, Dr. Vich, to this beautiful session that we are going to be having now with you and all the students across Mumbai. And today being a Saturday, some school students would probably join from home. And most of the schools have tried and got them under the umbrella in their own auditorium so that they could do this full scale thing for the students. They're very, very excited. We at the Sky Explorers are very, very excited to have you. And I'd like to start by saying thank you for always being there. And I won't say just being there for the Sky Explorers, which we always know you guys are there, but being there for the student community. And I know the passion that you carry for this. I will never, ever, ever forget our first Cosmic Fest where the students refused to want to leave you and Jan Gandhi sir that evening. I won't say it's an evening, it was night, literally 9 o'clock in the evening. And it just shows how much the students love to interact with you guys and how much you love to interact with them. And that's in itself a very, very big thing. So, on behalf of all of us, from the bottom of our hearts, I would like to say thank you so much. It feels extremely privileged to, actually interact with you. Um, and of course, Umesh is not here right now, but even him. And all of you who have become such an important family to us, I take the liberty to say that. And welcome. Today, students, talking to me here for you this morning is Professor Vig. Uh, you know, words fail me when I talk about her because, in her own right, she has achieved so much. So much is an understatement. Uh, as a woman scientist, she right now works as a professor at the Indian Institute of Space Technology. Uh, People who have been with us regularly will know Professor Rich, will know have seen her, met her at the Nehru Science Center with us, and interacted with her. People who have attended her lecture with us at the planetarium in the first Cosmic Fest would know the value that she adds. She's very, very passionate, extremely passionate about astronomy. Has studied a lot and done her PhD also from Italy. Please correct me when I'm wrong because I have so much about you to say that I don't know what to choose and what not to choose from here. So I think most of that I would leave it to you. She's also a part of the Astronomy Society of India, and not just a small part. She's also, correct me if I'm not wrong, the secretary, right, Sarita? Right? Yeah. So just imagine, and so much more out there. मेरे लिए तो सारा दिन कम पड़ जाएगा if I have to keep talking about you. So I will pass the
नहीं,
baton
आप
to you.
बहुत बोलते हो मेरे बारे में, मतलब
Yes, हम
थोड़ा
बहुत
कम
बोलते हैं
बोलना
लेकिन
चाहिए।
अच्छी बात है कि हम आपके साथ और आपके सामने बोलते हैं.
No, no, that is
तो
fine. I'm sure it is nice, but I think you flatter me too much.
गुड नो, वी नीड टू बी
No,
फ्लैटर्ड. ये दुनिया में वैसे भी लोग
not
ज्यादा फ्लैटर
always.
करते नहीं हैं, बट तो वैसे भी रोज कहाँ हम आपके मिलते हैं, तो फिर जब भी हम मिलते हैं वी लव टू लेट माय स्टूडेंट कम्युनिटी नो हाउ लवली अ पर्सन दे गेट एन अपॉर्चुनिटी टू बी विद. It only makes, I'll be very bashful, I'll be very honest, and I'll say it makes us feel extremely proud to flatter you. You deserve it. You deserve it. So gracefully accept it and say, keep doing it. My students would love to see that part of you. I'm so sure. My teachers that are there, my coordinators from all the schools across Mumbai that come and join, they love your people's lecture. They always get back to us and say thank you. But it should be me who should be saying thank you to them on behalf of the Sky Explorers because they come in huge numbers to attend you people's lecture, which makes us feel extremely happy about it. Yes, today being the eve, I would take the liberty to say of the total lunar eclipse. We thought, let's talk about the moon. I know this is also something which is very close to your heart. You and me, whenever we talk about teacher training programs, we talk about the eclipse and things like that and the myth around it. So while Altamash Pooja, myself, and the team, we were discussing as to what should be the topic or what should we be talking about. We said if we restrict ourselves to one little topic about moon, it would be unfair to the moon and to you. So we said we'll leave the ball in your court. We'll let you decide what you want to do. But we know we are all crazy and it's like a mania. So we said Moon Mania is a good idea to call this topic this morning. After your lecture, we're going to do a small little activity also with them about, making the little eclipse, which Pooja is going to take them through. So it's going to be fun. That's what we're going to make. If you see on screen, Pooja is holding it, for us to see. So we said that a little bit of hands-on would be good after your lecture. So yes, so without much ado, and I think by now a lot of people have already kind of joined in. So I was keeping that going so that if there are more people to join in, they wouldn't miss out anything of your talk. Uh, yes, thank you very much, Professor Vig. Let me officially welcome you and invite you to this beautiful session that you're going to be talking about the moon and the mysteries around it. And although it is so close to us, yet it is so far from us. We think we know so much about it from our ancestors up till the research that is happening in the skies on Earth. We still haven't studied, which is what we say many a times. So yes, the ball is now in your court, and it's time for me to keep quiet. Before that, just two little things. We will have a question and answer session at say around. Is it okay for you to? How much time do you need? Half an hour,
I think
45 minutes?
40 minutes. Yeah, half
Great.
an hour, 45 minutes is perfect. Yeah.
Great. So when you're done, you can tell us, and then we'll open house to questions. I request all the student communities, teachers, and everyone who is here and has a question to please type it in the little comment box over there. I am going to be monitoring the question. I will try my best to get all your questions answered. I assure you that much we will be doing. But just a small little request, when you like something what Professor Vich says, I would want you to use the emojis like the one I am putting right now, which is going to be saying that I'm loving it. Right now, I'm trying to be McDonald's, but yes, you can put your thumbs up, you can put those lovely emojis to let her know that you are enjoying it, and you are kind of there with her throughout this lecture. See, online, this is one thing that we always need to tell the speaker, that we're really there, we're enjoying it, and the speaker gets motivated to give us more. So you guys can use the clap emoji when you feel something is really, really nice. I do that. I'm so sure, Professor Vich, that won't disturb you. Yeah, but we'll send you lovely heart emojis to say we are enjoying this lecture. Thank you so much, students. And I think enough time for me to say thank you, and over to Professor Vich.
Yeah. Thank you, Mumtaz. या मैंने बोला तो था आप बहुत बोलते हो पर बहुत अच्छा भी बोलते हो. Okay. So yeah, thank you so much for inviting me. And without too much ado, we will move on to the moon. Okay, I'll switch off my video now to help with the network connectivity. But first, I'll switch off my video and start my presentation.
Can I sign out and sign in?
My screen.
Yes, we can see your screen, ma'am.
Hello.
Yes, we
Yeah.
can see your screen.
Yeah. So good morning, everybody. It's a wonderful day to be here. And as you can, Earth is moving around the sun. And as you can see, the moon is moving around the Earth. I think what is important for you to note here that when the Earth is moving around the sun, it is not moving randomly. It can move in all possible directions, but that's not what it does. It always moves in one particular plane around the sun. Similarly, when you are looking at the moon moving around the earth, you notice that the moon also does not move in all possible directions around the earth. It moves in one particular direction or one particular plane, as we call it, around the earth. So the direction, that line which is shown of the earth is the earth's axis. Okay. And that is tilted, as you know, 23.5 degrees with respect to the plane in which the earth is moving around the sun. So you must have see what is this is something called this is a movie which is made over many days, as you can see from the dates. And what do you see? You see that the moon gets lighted up, completely lighted up, and then it becomes dark again. Okay, so when you have seen, you must have seen the moon in the night sky, and you must have seen the moon doesn't always look the same. For example, sometimes you don't see the moon, you see part moon, you see full moon, you see quarter moon, and so on. So this picture, for example, shows you this entire cycle. So these are called phases of the moon. Sometimes you see crescent moon, sometimes you see gibbous moon, sometimes you see quarter moon, sometimes you see full moon, sometimes you don't see the moon. So this picture very clearly shows why you are seeing this kind of phases of the moon. Very often people, get confused that, as you can see, phases of the moon happens because of part of the moon doesn't get brightness. But this is not because of Earth's shadow falling. The phases of the moon is because only part, as the moving moon is moving around the Earth, only part of the moon is getting lighted up by the uh, sun's rays. Okay, so it's not that the Earth's shadow falls on the moon. When the Earth's shadow falls on the moon, then there's a special event that occurs that is known as the lunar eclipse, which is going to happen tomorrow. But the normal phases of the moon, they do not require. Normal phases of the moon do not happen because does not happen because of that, but it rather happens because only part of the moon receives the sunlight from the sun. So let us look at this part in detail. So as you can see, this picture, it starts off from where? It starts off from 1st September and it goes on and then it completes in around 27th, 20th September. So slowly the crescent you will see is completed. Now you see sunrise, sunlight falls and slowly that part of the moon which is bright or illuminated, that increases till it becomes full moon, and then slowly on the other side we see the illumination going off. So these are the different phases of the moon. You can see the names here, and then you can try to relate to what we saw here. So the new moon is when the moon is completely in shadow, completely dark, in the sense it's not the shadow. When the moon, there is no light falling on the moon, that is the correct way to say it. And then you have the waxing crescent. When you're saying waxing crescent, this is the part of the moon, this is waxing when the moon brightness is increasing. When the moon brightness is decreasing, that is called the waning part. So now this is the crescent. Why is it called waxing crescent? Because the brightness on the moon is going to increase as days go by. That's why it's known as a waxing crescent. Then you can see the first quarter of the moon, that is known as waxing half moon, and then you have a waxing gibbous. Gibbous means when it is more than the quarter. When it is less than the quarter, it is known as crescent. When it is more, then it is known as gibbous. And then you have the full moon. Then it starts decreasing. The bright portion of the moon starts becoming smaller and appears to become smaller and smaller. So you have a waning gibbous moon. Then you have a last quarter, and finally you have the waning crescent moon. So now you know these are the different names that we typically call the various phases of the moon, and try to relate it with this. This is the waxing crescent, quarter, and then gibbous. So let's go again. Waxing, quarter. So the waxing part, you have the crescent, you have the quarter, and then you have the gibbous and full moon. Similarly, you have the, when it's decreasing, you are having the waning quarter, waning crescent, quarter, gibbous, and so on. Okay, so this is how it looks like if you have to relate. For example, this is the new moon, this is the waxing crescent, first quarter, waxing gibbous, then you have the waning, then you have the full moon. After the waxing gibbous, you have the full moon, then you have the waning gibbous, then you have the last quarter, and then you have the waning crescent moon. So why do you see these different phases of moon? On which part of, where should the moon be for you to be able to see these different phases? As I said, this happens because certain portion of the moon is illuminated, not because it is within Earth's shadow. So for example, if this is the sun on top, whose rays you can see in this yellow, the full sun is not shown, only the rays you can see here. Can you see my mouse, by the way?
Just move the cursor. Yes, we can see your cursor very much.
Yeah, yeah. So if you are looking, these are the this is where the sun is. You can see the rays of the sun, and this is when the earth is moving around the sun. So as the earth is moving around the sun, the moon is also moving around the earth. So you can see this moon's motion is shown as it is moving around the earth. Now when the earth, for example, is located here, between I mean in the direction, so that the sun's rays fall directly on the moon this side, the part that we will be seeing is the dark part. And this happens in the daytime, right? Because it is in the direction of the sun. So since we are seeing only, we are not seeing any illuminated portion of the moon, that is known as the new moon. Then as the moon starts moving, then what do we see? We start seeing a part of the moon which is illuminated by the sun. This is known as the waxing crescent. And when it comes here, this is the first quarter. As you can see, it is here. This is the first quarter, and you will see this in the evening. So this, you will see this in the, as you are going in the after late afternoon, you will see this. Then evening, you will see this. And then when you come here, you can just after the first quarter, you will see the gibbous moon. So the gibbous moon you will see on the night side. So as you can see, you will be seeing the new moon phase when the earth is facing the sun, that is during the day. And then slowly the crescent is going to increase. That means after the daytime, in the evening and all, you start seeing the waxing crescent. And then in the evening you will see this, because this is daytime, this is nighttime, and this is the evening portion. So in the evening portion you will see the first quarter, because you will see this part which is illuminated by the sun here. Now once you move behind, this is the gibbous, where you will see a large part of the moon.
Sarita, can you hear us? Because we can't hear you.
Hello.
Yeah, we can hear you now.
Okay, so probably you missed some part, right?
That's true. Just hardly.
Huh. So
Yeah, that's the place where you can start.
yeah. So as you are moving towards, as after evening, in the as night advances, you will see the waxing gibbous, where you will not see the fully illuminated portion of the moon. You will see most of it, but not completely. And once it moves here, then you will see the fully illuminated portion of the moon, that is known as the full moon. Then again the cycle continues. You, it starts waning, and then you see a waning gibbous, and then you see a last quarter, then you see a waning crescent. Now you are going towards morning. So if you are seeing a crescent in the morning, it means it's a waning crescent. If you are seeing a crescent in the evening, it means it's a waxing crescent. So from this you can tell whether, when the crescent is seen, that will help you tell whether it is in the waxing phase or in the waning phase, till it comes back to this part, which is the new moon phase. Now, I don't know if you have this question, but if you see that here, because the slide is a 2D, the slide which I'm showing you, that is only a two-dimensional structure. So if I'm putting the moon here and I'm saying I'm seeing only this part of the moon, it would appear that the sun is, that the moon is blocking the sun. And when I come here, you will see that this is the new moon. So it appears that the earth, it is in the moon's shadow, but that is not correct, because the plane of the moon's orbit around the earth and the plane of the earth's orbit around the moon, they are not in the same plane. They are tilted. Okay, there's a small shift between them. So I'll come to that part. So this is, I'll come to that part soon, and I will try to show you through a figure. So these are these different phases, as you can see. So in the, as we have seen in the, at noon, you will see that this is the direction of sunlight coming, and this is the new moon. And new moon you will see at noon, for example, and then as it is increasing, you will see, and this is what happens, that let us say at 6 p.m, this is what you will see. And as you are increasing, as the days go by, you will see different phases of the moon. So in one, in position 1, you will see the new moon. In position 2, you will see waxing crescent, waxing quarter, first quarter it's also known as. Then you will see waxing gibbous. So in principle, this is how the moon will be illuminated, but depending on, because of our location of earth and the location of moon with respect to us, we see these different phases. So ultimately the moon is this, which is getting the half which is facing the sunlight is always going to have be illuminated, but we are seeing only small portions of it. And when it is here, we are seeing, for example, if you are standing here, you will see that it is fully illuminated, and as it moves slowly, you can see that the waning phase begins. So as I was mentioning, if you think of both the moon's orbit around the earth and the earth's orbit around the sun to be in the same plane, then it would appear that the earth would be that the moon would be in earth's shadow, and therefore you should not see the full moon, right? So if the earth was really blocking all the moon light coming from the sun to the moon, you should not see a full moon. But we do see a full moon. That is because this is slightly above the plane of the slide. Okay, since the moon is slightly above the plane of the slide, the light from the sun is able to reach the moon, and when we are seeing the moon, you see it as a full moon. So that tilt between, as you can see here, the plane, there are two planes here. This is one plane, which is the plane of orbit of the earth around the sun, but the plane of orbit around the moon is tilted with respect to plane of orbit around the sun. So if they are in the same place, then it will be in the shadow of earth, that is known as an eclipse. But at other times, for example, when here, for example, if you see this position, in this position the moon is such that it is above the earth's plane around the sun, so the sunlight can reach the moon, and therefore when you are seeing the moon here, it will appear like a full moon, and this will appear like a new moon. So in most cases, this happens. The earth does not completely block out light and so on. But in some cases, sometimes what happens is that the earth, moon, sun are in line, and that is when these special events called eclipse occurs. So before I move on from these phases of moon, as you can see, I'm showing it again. I hope you know the Hindi, I mean, names of the, I mean, Hindi or your local language names. Generally, the waxing phase is known as the Shukla Paksh. That means that typically last waxing phase. So the total time for the moon to go from the new moon phase to full moon phase and back to new moon phase is typically 27-28 days. The waxing phase is also known as a Shukla Paksh, which is typically 14 days or so, and the waning phase is known as Krishna Paksh. That is when it is becoming, what you say, the illuminated portion becomes smaller. And the full moon is also known as full moon is also known as Purnima, and the new moon is called Amavasya. So you must have heard this terminology because very often our Indian festivals and are related to the phases of the moon. Okay. So now I want you, so apart from, so this is one part which I wanted to introduce you to. What are the phases of moon? I think it is important for you to take back that the phases of the moon are is not because of the shadow of earth falling. It is because of the geometry, the way the moon is always illuminated by the sunlight in the half that is facing the sun. But depending on where we are, we either see the fully illuminated moon or we see the partly illuminated moon. So it is important to understand this particular aspect, that the phases of moon occurs because of earth's position with respect to the illuminated portion of the moon, and it is not because of the earth's shadow on the moon. So now I want you to, for example, see this figure, and I will tell you what this figure is. So this figure, the circle in the middle, for example, indicates the earth, and that picture that you are seeing which is moving around the earth, that is the moon. So typically the moon takes 28 days to come back to the same position, from new moon to new moon or full moon to full moon. It is typically 28 days. Now there is a small difference in the way the moon is rotating around the moon is moving around the earth. I want you to take a moment and note, is there any difference between the two, or is it the same?
It is same.
Carefully you look.
In size, difference in size.
In the
Are
second one,
you seeing a difference in size?
in second one,
Yes.
the shadow is still. In the first one, the shadow is moving. Like the
Yeah. Sorry. The portion which is, there is some dark portion of the moon, right?
yeah. So
On the moon there is something which appears darkish.
in the second one, it's still, and the first one is moving.
Yes. So the first one, how is it moving? It is always facing the earth.
Yes.
But in the second one, it is not facing, it is in the same direction always. Correct? So it is just that the moon is moving around, always it is in the same direction. But in the first case, if you see that the dark portion is always facing the earth. Now, which is the case that represents the actual moon? Is it the first case or is it the second case? So I'll tell you the difference between the two. So if this is the earth, if you are standing at a position on the earth, and of course the earth is also rotating, what we would see in the first case is you will always see the dark portion, that darkish spots like thing on the moon. But if you are standing in on the earth in the second case, you will see different parts of the moon. Am I right? As it completes one rotation, you will see different parts of the moon depending on wherever you are. Remember, earth is also rotating actually. That is not shown here. So if you can assume that I am able to stand anywhere on the earth, then in the first case you will always see the same part of the moon wherever you are standing and whenever you are seeing. On the other hand, when you see the second picture, you will see that I can see the different sides of the moon. Now, which is the correct picture that represents how the moon moves around us? Do you have any idea? Okay, then let me tell you. So, as it happens, the first picture is the correct one. We always see the same face of the moon. We cannot see all the sides of the moon. That's why when you look at the moon, it always appears very similar, right? Full moon to full moon, full moon to full moon. You see, do you see different parts of the moon? No, you always see the same side of the moon. Okay, that is because in the first picture you will see that as it completes one revolution around the earth, it also completes one rotation itself. So the moon's rotation time period, how much time it takes to rotate around itself. So, as you will see, the moon's time period of rotation and the time period of revolution is the same, which is 28 days, and that is why the we see the same face of the moon. On the other hand, in the second picture, the moon is not rotating at all. It is just revolving, but it's not rotating. Whereas in the first case, look carefully, it is rotating.
Laptop skin.
Okay, so that is another aspect of the moon, that the rotation time period of the moon is same as the revolution time period of the moon, which is 28 days. So this is the face of the moon that we always see. Okay, that is always visible. This is a high resolution picture of the moon, and as you can see, there are areas which are dark. That is why it showed up as dark patches, and we always see this face of the moon. Now, how does the other face of the moon look like? Unfortunately, from Earth you cannot see it because the same face of the moon is facing us. So, if you really want to see the other side of the moon, then you have to go out in space behind the moon to be able to see that portion of the moon. Okay. So here, these dark portions of the moon, for example, so there are missions that have gone and taken picture of the other side of the moon. This is the side, left side is the near side, means the side that is visible to us. Far side is the side which we can never see from Earth. So as you can see, there is a big difference in the far side of the moon and the near side of the moon. And it is only in the near side of the moon that you are seeing some of these big, large, dark patches, which is not there in the far side of the moon.
The color is
Okay.
different.
Yes, so they are the
In
dark
near
patches.
side, some black dots are there. In far side, no black dots.
Yes.
Very good, Arush.
Thank you, ma'am.
So if you are looking at these dark patches, these dark patches are known as the mare. Okay, they were given certain names. They are called mare, and the whitish patches they are known as the terre. So the mare is because initially when people did not know about the moon, they thought that the dark portions represent the seas or the oceans. Okay, because mare in what do you say in Italian or it represents the sea. Okay, so they thought that these were seas or oceans, that's why they are darkish in color, whereas the whitish in Latin actually, and the whitish portions are the land or the terre. But those names have stuck even though now we know that there are no oceans on the moon. It's just that the soil composition is different in the region, in the dark patches it's more reddish in color as compared to the other regions. So here, as you can see, there are these dark patches called mare, and they have even been given names because people have spent time trying to identify the various features on the moon, and they have given various names. So you can see that's Mare Frigoris, Sea of Cold, Mare Serenitatis. Then there are oceans, Mare Cognitum. There are various kinds of names they have given to these different dark portions. Now, if you see the surface of the moon, you also see the small circular features. Okay, the small circular features you can see are there both in the mare. For example, the mare itself can be circular, as you can see here, but you can also see the small circular features here. So these circular features are craters. Okay, so as you can see here, they have also been given names. These craters can extend on the moon, can extend from micron sized. That means they are 1 millionth of the size of a meter, and it can go to up to several hundreds of kilometers. So the big ones that you see here, they are very large, and they have also been given names like Grimaldi crater and so on. The or yellowish ones are the craters: Copernicus crater, Aristarchus crater, Kepler crater. So these big ones have been given, which we can identify easily. You can probably see them with good pair of binoculars. With a telescope, you'll see them very well. So these are these structures which are kind of small bowl like structures, katori like structures on the surface of the moon. Now, why do you see so many craters on the moon, whereas you don't see any craters, that many craters on Earth? On Earth, for example, there are only a few craters. And what causes this crater formation? So these craters form because when there are these other solar system objects they are passing by, suppose they hit the moon, then it will cause this. It's like throwing. It's like if you have the surface of the earth and you throw something like a huge boulder kind of thing at very high velocity, you throw it on the earth, very high velocity, mind you, then it will cause a small hole like structure, like a bowl like structure. So that is known as a crater. So on the moon you have very large number of craters. This is because as these objects come by and they hit the moon, then on the surface of the moon these craters are formed. But why do you have so many on moon but you don't have as many on earth? Is because the moon has no atmosphere. So as a result, what happens on the earth, because of the atmosphere, all the objects which are coming towards the earth, to a large extent they are slowed down and they are oxidized and they burn up. So you will hardly find very big objects coming and hitting the surface of the earth. But there are a few craters which are believed to have happened because very long ago there were these meteors that hit the surface of the earth. For example, in Maharashtra near Aurangabad, there is a crater called the lunar crater, and that is believed to have been formed due to the falling of a meteor, which is a meteor maybe 40 to 50,000 years old. They are still trying to figure out how many years ago this event happened. So these small circular structures are called the craters, and you see a large number of craters on the moon because it hardly has any atmosphere. Now let us look at these very special events called eclipses. Okay, so you there are two kinds of eclipses broadly. One is the solar eclipse and other is the lunar eclipse. So what is the solar eclipse? First I will talk about, then we come to the lunar eclipse. So as you have seen that when the moon is moving around the earth, there are times when it can happen sometimes that the earth, moon and sun are in line. So when the Earth, Moon, and Sun are in line, whether it is in this configuration or this configuration, then there is a shadow which is falling either on the Moon or on the Earth. So as a result, what happens is you will see some portion of the light blocked when you see from the Earth or when you see from the Moon. So when the Moon comes between the Earth and the Sun, then for some people who are located here, as you can see, they are for them the complete sun is blocked out. Okay, but if you are here, a part of the sun is blocked out because the moon comes in the path of the sun. So this is known as a solar eclipse. On the other hand, when the earth comes in between the moon and the sun, then the moon comes in between the shadow. Now the moon is in the earth's shadow. So this is a clear example. When moon is in the earth's shadow, that is known as a lunar eclipse. So the event that is going to happen tomorrow, I think, which starts at around the full eclipse. So it can be part eclipse, it can be full eclipse. So the part eclipse will begin around 9:30 or something of that order, and the full eclipse begins at 11 o'clock and goes on till around 12:23 or so. So this is how the solar eclipse looks like. So I will just show you picture of solar eclipse and lunar eclipse. So the solar eclipse, as you can see, will happen during the day, and you will see the moon slowly. Suppose it's a total solar eclipse or an annular solar eclipse, you will see the moon slowly coming in the path of the uh, uh, sun, and not coming in the path of sun, blocking out the sunlight because it comes before the earth, and slowly you will see this kind of effect. And after it, as the moon is passing by, slowly the sun starts becoming visible again. This is known as an eclipse. So this, if it is a, if the moon is able to completely cover the sun, then you can't see the sun. But there is some radiation around the sun, which is known as the corona. You can see that clearly. So this is a very beautiful cosmic phenomenon, which every time, which is quite rare actually. So if you get opportunity to view this in the coming years and from a location that is accessible to you, then it is definitely a very beautiful phenomenon to watch. Now let us come back to the lunar eclipse because that is the event for tomorrow. So again, to reiterate, lunar eclipse occurs because the earth comes between the sun and the moon, and therefore moon is in the earth's shadow. So how does the moon look like? So I would urge you all to see the lunar eclipse tomorrow. So this is what it looks like. So this is when, this is the white light which is coming from the sun and getting reflected off the moon. So you will see something like this. Then when the earth's shadow starts falling on the moon, then it appears as something like this, and so you will see something reddish, and then it goes off. So ideally, you should say if it's a shadow, then why are you able to see even reddish? Why does it appear reddish? This is also known as blood moon, by the way. So this reddishness happens because some Earth has an atmosphere. So even though Earth is completely blocking out the light from the sun, some part of the sunlight can get pass through the atmosphere and get uh, refracted. It is known as refraction because through the atmosphere the light rays will move towards the moon. It does not pass off straight because the atmosphere is another dense medium. So the light from the sun will pass towards the moon, and that is what, and that scattering of light towards the moon happens more frequently or happens more easily for red light than for blue light. Therefore the moon appears reddish in color. Okay, so although earth is blocking out the light from the sun for the moon, some part of the sunlight can still leak in because of this refraction or scattering, and that is the red light that scatters. And that's why when this red light reaches the moon, it scatters back to us and it reflects that light back to us, and that's why the moon appears reddish in color. So this is a lunar eclipse. So now you can see a lunar eclipse from Earth, but you can also go and see from the moon itself. So when you are seeing a lunar eclipse from the moon, then you will see the Earth. Okay, and shows the Earth for there. Now if you are seeing from the moon, right, what will they see? They will see, if a person is standing on the Earth, in this case you would see, if a person is standing on the earth, what would you see? The moon is blocking out the sunlight. But here, what would you see if a person is standing on the moon? You will see that the earth is blocking out the sunlight. So if a person is standing on the moon, then for him or her, it is going to be a solar eclipse. But the solar eclipse happens because of the earth, and that is what is shown in this picture, which was taken by the moon probe Cayuga in 2009. Okay, so this is an interesting event, the eclipse. I would like to mention few things that usually there are a number of superstitions which are associated with eclipses, both solar and lunar eclipse. Okay, where they say that these are not good times, it's not good to go out. But now you know, this was all this happened because people were not aware about these cosmic phenomena. They did not know that the earth was moving around the sun, moon is moving around the earth. So therefore, according to geometry, when one comes in front of other, then this kind of eclipse occurs. All that they knew at that point of time, when most of these superstitions or most of these practices began, is that suddenly the sunlight is blocked out or suddenly the moon becomes very dark. So if you don't know, the answer is when some of these practices would have begun. But now when we know that it is just a shadow play, So we need not worry too much about not eating and not doing things and so on, because it is just a cosmic shadow play. Earth coming in the path of sunlight to the moon, moon coming in the path of sunlight to the earth. So it does not really matter about what these practices, what you should do and what you shouldn't do at some point of time. In fact, what you should do is, now that we know why this occurs, is go out and enjoy the phenomenon and carry on with your normal daily life and daily routine things as you usually do. I think this is all that I have to say for today. So thank you very much.
Thank you so much. I think we deserve a big round of applause. So we are all going to send you these lovely claps from our emojis and a big
Thank you
heart to make
again.
it so interesting. Oh, I can see some people tapping their tables, which is beautiful.
Yeah,
No,
yeah.
I think this
Thank
was
you.
lovely, lovely. I'm so sure. The moon is something that is at least one of that celestial objects which is generally spoken about more often than anything else. We also take it for granted. Having said that, because we see it practically every day. All right, and we hear it. The best part, what I like about the moon, is it is so seeped into our systems right from a child is held in the mother's hand and passed on to the grandparents' hand. The moon starts becoming a part of our life. Uh, Parents start telling us stories when we do the first annapradashan, okay, and the child is fed the first morsel. I've seen a lot of people generally, telling the child, look, 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 the moon is there, Chanda Mama, and he becomes a relative of ours by this word called Chanda Mama. And what I like all about it is हमेशा मम्मा की साइड से आ जाता है, तो वो और भी क्लोज हो जाता है हमारे दिलों में. So moon is such an integral part of our lives, yes. And this celestial phenomena that keeps happening now and then with regards to the eclipse always makes me wonder, with the clockwork precision that nature is working, that the universe is working out there. And I think tomorrow evening when this starts up there, the the thing that I am waiting to see is how the earth starts creeping and slowly, slowly covering that moon. And it feels like the earth is eating a little bit of Oreo. All right, a little bit of Oreo. We relate to that because that is something that we love to do, eating an Oreo or eating a biscuit, and then that little curve that comes in, and the bite gets bigger and bigger, bigger. Out so beautifully with all the lovely slides that you kept animated, you kept it going, you kept it engrossed. I'm so sure students, you have loved this. Let's give Sarita ma'am a big heart. Okay, I'm going to do this, and I'm going to do also the lovely pink heart that I can see all of you sending. It makes us feel so good, so good. Yeah, and yes. So,
Yeah, thank you very much.
and all of you, thank you for being so attentive, for answering and taking a shot at the questions that was asked to you. You may type your questions here if you want. Do you have any questions? Okay. Uh, I have a question here that I wanted to ask, and sort of, which is something all the entire scientific community always keeps thinking and wants to work around, and that is about the awareness that is around the superstitious bit of it about eclipse. And it's not just in India, we all know it, it's globally. So this superstitious part of eclipse is a global phenomena that we see. And how do you think this awareness actually can spread more faster? Who do you think would be the most instrumental? Yes, Sadia, we're going to ask you. Can you type your questions with that?
Yeah,
Yes.
so I think it is, you can only get rid of superstitions with knowledge, or with the understanding of why this phenomenon occurs. So, in all possible ways, once this goes out to the people, the children, because most of the older generations, they would have grown up with this, so it's not very easy for them, uh, because they would not probably also know the reason. So it is the children, once they know about this, they can tell in their families, and they can explain it to everybody else. And I think awareness in all possible ways, through all possible means, one can think of, and holding. For example, if you talk about locally doing it, then locally doing it, if you're holding such events, then actually have people eating food and so on during that phase, and say that really nothing's going to happen. It doesn't really matter what you're doing at this point of time, because the as I said earlier, it was largely our not knowing what causes these phenomenon led us to some sort of fear that you don't know what's happening. Suddenly the sun went dark, suddenly the moon went dark. But if you know the answer, then it's not really as fearful or scary as what you would have thought earlier. So I think if one wants to do it, we have to educate as many people as possible regarding this, and that's the way to go forward.
Yeah, perfect. I think it's so true. And, as you rightly said, it's a student community who can bring in much bigger and a faster change because they have access to the grandparents, they have access to parents, although each one of them is busy in their own little world. But when children speak, we listen. We always listen. So I think children, you should go about talking to your family, to your friends that, wow, today we attended this lecture, we got a bit of clarity on how a lunar eclipse takes place. And there's this naughty earth of ours, it comes in between the moon and the sun. And, you could probably take a pen and a paper and everything that you saw today on screen with Professor Vij's lecture, you can draw and explain, and you can become the little teachers to all of us. We have Sadia putting her hand up. Sadia, would you like to talk? Yeah, you're resonating, and that's the reason we generally encourage you to type the question. But you can try again. Yes, Sadia, we're waiting. Okay. By the time Sadia is either typing or trying to figure out, anyone else has a question here? I have a question, Professor Rich. We generally, we are saying that we generally from Earth only see one side of the moon. Okay, but we also know that the moon is also, turning on its own. So if that is the case, if you could shed a little bit of a light for the students, that what do we mean that the moon is tidally locked, so that we see it's one side all the time, but at the same time, the moon is moving. So why is it that is the speed of the moon which is doing that? Is it, if you could just put that there.
Yeah. So I think it's related to, it's not the speed of the moon is more or less constant. It's not related to the speed of the moon. It is the simply the time period. It's like if you can do this exercise with two people standing also. So one person is the sun and the other person is the moon. So if the person is facing and moving around and coming back, he's continuously facing this person and coming back. You will see that is the same face the person, the sun is seeing, right? And that uh, on the other hand, if I remove that person to another place and ask him to turn around, that's exactly what he does. In one turning around, he comes back to that same position. So the thing is, it becomes a bit difficult for us to follow in this scenario because both rotation and revolution are happening simultaneously. And that makes it a bit difficult for us to understand. But the fact remains that it is one rotation and one revolution. So when you have a rotation, if you have two revolutions or two rotations in one revolution, then by the time you come back, you would have rotated twice. Okay, for example, Earth takes 365 days. That means 365 times it is rotating when it moves around the sun. But if it was doing only, let us say the Earth was the one Earth day was one Earth year, which is precisely what is happening for the moon. That means the time period of rotation is same as the time period of the revolution. Then Earth's same face will be receiving sunlight. So one part of Earth will always have day, the other part of Earth will always have night.
Wow, thank you so much. That is so enlightening. There is a very beautiful question from. We're also live streaming this on YouTube. So from that side, we have a question: what would happen if the moon did not orbit the Earth?
If it did not orbit the Earth, it would just fly off,
Exactly.
right? Because it has a certain energy or momentum with which it is moving, but this angular momentum or the gravity keeps it moving in this direction. But if this was lost or Earth vanished for a moment, okay, if it did not revolve, means I would say for a moment, poof, the sudden Earth completely became vapor. Then the moon, which was moving around the Earth, that will suddenly move off.
Yeah, there's a lovely question. Why does moon become red during a lunar eclipse?
Yeah, so the moon becomes red because as I said, that although the Earth is blocking out all the sunlight reaching from the moon, but there is the Earth's atmosphere, which is a layer of air, dense air, above the Earth's surface. So some light from the sun can get refracted or scattered through this onto the moon. And the scattering of the light is more for the red light than the blue light.
And it's so beautiful, right? When these little phenomena keep happening, light plays its own dance, and we see the different impact that it happens on these celestial objects. It puts us in awe. And I think the best part about astronomy is how it humbles us, how it makes us realize that we're actually, I won't say nothing, but so fractions, such a small fraction of this universe. Well, taking it to the next thing, Naira has a question. And Naira, if you've heard ma'am talking, I think your question had been answered, but we'll take it up again. It says, lunar eclipse and Amavasya, are they almost the same?
Yeah, I had one more also.
Yeah, we'll finish this question first, Naira.
Yeah, sure.
Yeah.
Thank you, Dave.
Yeah, so lunar eclipse is not Amavasya because every Amavasya you don't have an eclipse. Eclipse happens because the Earth comes in between the moon and the sun, so the shadow of Earth falls on the moon. But Amavasya is not that. Amavasya means we are just seeing the dark side of the moon. The moon is getting illuminated. It's not in anybody's shadow. So when you are having a ball and there is a certain light coming, then you will see dark portion whether you are here, whether you are here, whether you are here. If you are standing here, then the dark portion you are seeing because the light is getting blocked. But if you are standing here and seeing, you are not in straight line. You will. So normal Amavasya is when Earth is not in straight line with the moon and the sun, but you are seeing the dark side of the moon, which is not illuminated by the. You are seeing the portion of the moon which is not illuminated by the sun.
Janisha has a very beautiful question. Because of the lunar eclipse, is there any change in the gravitational force on Earth?
No.
You know, children, when you ask these questions, they're very nice. They're very, very nice, and we feel nice that you're asking. But also start visualizing your questions, because when you start thinking and when you start putting logical reasoning, a lot of things you will learn besides only your question. Am I right to say that, Professor Vig? Yeah.
Yes.
So we
right.
have Naira. You wanted to add something to your question?
So ma'am said that if the moon doesn't orbit the Earth, so it like goes away. So what effects can it have on Earth? Like are there any effects?
Okay, so this we are going in the realm of fantasy. Because
Correct.
you love stories. We all love stories. So the thing is, as I said, the Earth can move off if the moon can move off if the Earth disappears. So it will not have any effect as such. The moon continues to move around the Earth because of the gravitational effect, and because the moon has this rotation, some angular rotation effect, right? Rotation or revolution effect. So these two, and it's called angular momentum. I did not want to use the terminology, but this is what it tends to keep the moon moving around the Earth, right? So it will continue like this unless there is something which is going to come and disturb it. When I say continue like this, will it continue for infinite time? That is what physics study. But when we talk about those time scales, I think they are much, much larger, on really very large time scales. Maybe some effect will be there, it will slow down and so on. But on for all practical purposes, on the time scales that we know, which is like several hundreds, thousands of years, it is expected to keep moving in the same.
Right. And as we know, that the moon is also moving away or drifting away from the Earth, right? Every year by a centimeter or so.
Yeah, but that is very, very little.
Exactly.
Yeah.
So imagine
That's
after
because of the slowing down also.
Yes. So imagine after thousands of years, of course, we won't be there to see this phenomena. So maybe, Naira, what you said, what if the moon, this would come true probably. And then, of course, we wouldn't be there. So let's hope and pray to see other things and learn other things. Yes, Arush, you had a question, my dear. You're on mute. Arush, did you have a question? Okay. Sumedha, we'll pass it on to you. You have a question. Yes, Sumedha, we can't hear you, but you have unmuted yourself. Sumedha, we can't hear you, but probably you should type your question. That becomes very easy. Okay, there was a DS who had also risen his hand. Sumedha, you may
I
type
think
it.
Sumedha had typed the question, why is the moon moving away from Earth?
Oh,
It
I
is
can see that
precisely
now.
what you asked. And it is related to the slowing down, right? Because ultimately, if you keep anything perpetually moving, it requires energy, and that is not available, right?
Deep has a question here. He said, you know, Deep Sarita from my teeth. He says the size of the moon is shrinking. What could be the reason?
Well, I want to know the source of this information.
Yeah, exactly. So, Deep, you will need to get that checked because this also came as a little bit of a whopper to me. So we'll make Deep work on this, and next year when
Yeah,
you're going to be talking about eclipse, we will
sure.
catch hold of Deep with more information
Yeah, yeah.
about that, right? But Deep always comes up with these lovely one-liners, and we'll make
Yeah,
him work
it's possible
backwards.
that, and I would like to know not only the source, I would like to know is, of course, that if it is true or by what measurements they have come to know that the size of the moon is shrinking and how much it is shrinking. So all these things, once I get an idea, it will be easier for me
Yeah,
to
yeah, yeah,
answer this. Because
certainly.
that's not something that is very prominent or that we know and it's really happening. You will see it today one size, tomorrow it will become half the size. ऐसा तो नहीं है.
I think we've answered Sumedha's question, right? Why is the moon moving away from the Earth? Yeah, it's the speed, the slowing down, so many other factors also which come into play. You just mentioned. Anybody else has a question? Because Professor Vig has other commitments at 10:30, so we won't keep her more than that. You may park your questions. You may send them to us through mails, through our Insta page. As you all know, we'll encourage you to go on our Insta page. And I promise you, we don't talk anything there besides astronomy. We don't talk any. We are very boring people. We don't talk anything besides these lovely celestial objects or things that we want to do as an outreach for you all. So do visit our Instagram page to understand. Professor Vij, please, I'm not trying to flatter you or anything, but every word that we use comes from the bottom of our heart because that's the way we express our gratitude to you and to your entire tribe who really, really support us in this thing that we are doing. Uh, I would want to thank you from the bottom of my heart. I think Sumedha's just typed one. Why did Earth have a second moon? Ooh, why did Earth
Again,
have a
I would
second
like
moon?
to know the source
Yes.
of this
I
information.
I think there was this news about a quasi moon some time ago, and a lot of students were asking about that.
That was
Yeah,
some
but
time back.
Mumtaz ma'am, you're on mute.
Think we'll skip that and you know what, Sumedha, we'll look for more sources for that and come back to you. Rest assured, if Altamash has your email ID, we'll get back to you on that. Thank you so much, Professor Vich. It's 10:30 on behalf of my entire tribe
thank
here
you.
in Mumbai, around Mumbai, and people from out of Mumbai who've logged in through YouTube, through our own link, and my entire team. We love to thank you from the bottom of our heart. We're looking forward to our next Cosmic Fest, or maybe before when we drive you and pull you out from your lovely workplace and everything that you do. Thank you once again. Really appreciate. Have a
Thank you
most
very much.
beautiful day.
You too.
Thank you, and
Bye bye.
and
Have
if
a
you
good
get
day.
to watch the moon tomorrow night,
Yes,
we are
I
trying
will.
to do that. We are
Yes.
trying to do that.
Good luck with that.
Thank you. We've organized a stargazing at Marine Lines
Mhm.
tomorrow and keeping all our fingers crossed for the clouds to not be
Yeah, yeah.
spoiled.
I think that's the only
Yeah.
thing
Yeah,
that
and we
is
are
worrisome
encouraging
right
all the
now.
people to see from their own building terrace because the
Mm.
beauty of a lunar eclipse is that you don't need to have any special glasses or anything. So this
Mm.
particular
You will see with
spectacular
the naked
dance,
eye. Yes, true.
absolutely, the students can get the treat even if they don't get to come to Marine Lines. They will still be able to see it from their buildings, their terraces, with their family and friends. So enjoy, have a lovely day, students. You hang on. We have a beautiful activity lined up for you before you
Okay.
go. Thanks.
Yeah. Thank you. Bye
Lots
bye.
of love to everybody at home. Thank you. Bye bye. All right. So, how are you doing, Bacha Padi? Lakshmi, our moon phase the same everywhere on Earth. Ma'am, our moon phase the same way everywhere on Earth. Lakshmi, that's a very beautiful question that you have asked. But you know what? We are very bad people at the Sky Explorers. We never answer these questions directly. So, what I will do is, I will give you these next 15 days, okay, to observe your own moon. Start drawing it like how Galileo did in his little book. All right. And at the same time, I'd want you to go out there, read about phases of the moon globally. And then maybe one of the days you can either call us up. I'm so sure Altamash's number and emails you have. Ask your teachers, your coordinators if you don't. And then we'll one-on-one talk to you about this, which will be even more, because by then you'll have more things to, argue with us, talk to us, and we enjoy these kind of discussions. So on that note, Lakshmi, I do hope that answers your question. Think about one single moon for one single earth. And now think about the phases. I'm so sure you'll get your answers, but don't depend only on those answers. Go out there and read and add on to your knowledge bank and share it with us. We would love to. I'm going to hand this over to my lovely Pooja here, who's waiting, and she loves to do these lovely things with kids. So, Pooja, all over to you.
Thank you. I hope all of you all have been enjoying the lecture.
Yes,
Yes?
ma'am.
Of course,
Perfect.
ma'am.
You can hear me, correct?
Yes.
Perfect. All right. I am sure all of you all must have received this one pager that was sent to you by your coordinators. Do you all have that printout with you guys?
I don't have, ma'am, actually. Forgot.
No problem. Why don't
Okay.
you draw on a piece of paper? Why don't you take a piece of paper, Arush, draw it, and quickly run and get a. We'll give you 2 minutes for everyone who doesn't have. Get a scissor and some glue and a piece of paper. You have to just draw
Yes,
on that paper if you don't
that's
have a
all.
printout. Perfectly all right. Come on. We'll give you that 2 minutes. Your time starts now. And when you are all ready, just start giving us thumbs up. So Pooja starts, getting into the groove and showing you how to make this lovely lunar eclipse. Arush, you have a printout? Arush,
Harush, Trisha, do you all have the printout?
Yes,
uh,
ma'am.
Naira, you can take a piece of paper, okay, take a pair of scissors and a glue. So do it with us, and of course, you can do it later also, but do it now. You'll enjoy it. You won't make a mistake. All right?
Yes. Once you have a paper like Mumtaz ma'am just told you, just draw three circles.
Of different
One.
sizes.
Yes. The biggest one will be our biggest and the only star in our solar system, right? The sun. And make another one smaller to it, which will be our Earth. And then we'll have the tiniest circle, which will be our lovely moon. Yeah?
Perfect. Okay, so can we assume that most of you have got this? All right? Yeah. Can we give a big round of applause to Pooja Didi, everyone? Come on. I'm sending Pooja some lovely hearts. Look at this. Wow. I've got people sending out these love. Oh my good Lord. You guys are lovely. Yes, sure. Come on. I think Pooja, you're good to
Okay.
go.
All right. So I'm assuming that all of you have now got all your three circles, right, which you've drawn. Now, what you need to do next is you need to cut them out. All right. So you'll have lovely circles. I have one ready for you here. Yeah. So you can cut it out. So you'll have three circles which are cut out. Yeah. One, two, and three. Yeah. I'm going to give you a minute again to go ahead and cut these circles. All right. And then we'll go back to the next step.
Ma'am, they are so
Let us.
cute.
Can you repeat yourself, please, Trisha?
Ma'am, they are so cute.
They're cute.
They're cute.
Nice.
Just like you, Trisha. Very cute.
Okay. Are we ready? Have we cut down our circles yet? Not yet.
Okay.
Lakshmi Priya needs more time. Okay. We'll wait for some more time.
So when you have cut your circles, what you can do is you can put your cameras on and just show your circles. Or you can do a thumbs up, which is perfectly all right. We understand if you don't want to put your camera on. Oh, wonderful. Pooja, a lot of thumbs ups are coming for you.
Perfect. Great. Now, on the sheet, there are also two strips, right? So, those who are drawing on the same page, what you can do is you can cut out two strips, all right? Make them slightly thick and nice so that you can stick them, right? And they remain strong. Yeah. Can we cut out two strips? There are two strips here. I will wait for your thumbs up once you have cut out the two strips, all right?
Once again, every time a step you finish, always give a thumbs up. So Pooja Didi knows that you guys are done. Okay, how many of you are done? Can we see your thumbs up? Okay, Naira,
Okay,
very
Naira is
good.
done.
Excellent.
Janisha is
Janisha,
done.
cool.
Perfect.
Okay, Lakshmi still wants 2 minutes. We'll give you Lakshmi 2 minutes. DS, thank you for your thumbs up. Okay, thanks, Lakshmi. I think you can give Pooja Didi claps also in between. She's doing such a wonderful job.
All of them are doing a great job.
Yeah, we can't see them, we can see you.
We'll clap for each other.
I think we're good to go to the next step.
Perfect. So now we have a strip ready. Yes, we're going to take our first strip. All right. Those who are using the printout, you can make sure that your dot here, which has been given, is on the right hand side. For those who have plain strips, it doesn't matter which side you have used. All right.
Your right hand side, or wherever the dot
Yes,
is.
your right hand side. Yes. Now, on the other end of this strip where there is no dot, right, we will go ahead and stick our sun, all right, and we'll stick it at right at the edge so that we get a lot of space. Yeah, as you can see, I'll be sticking it right at the edge. So there is a lot of space. Good idea? Can you do that? And I'm going to do it with you. Okay. There we go. Do you have your sun stick up now? Give me thumbs up if you're done. Very good. So Lakshmi Priya is done, Trisha is done, Janisha is done. Great. So let's move to the next step. Yeah. For those who are using the strips which are already printed, yeah, you are next going to take your little earth. All right. And what you will do is you can see the logo here, right next to the logo, right? Touching the logo, you're going to place your earth. For those who don't have the printed strips, you can just place it in the center. So that's not an issue. All right. Let's go ahead and stick our earth now. Well, I can see that Naira, Lakshmi Priya, you're already done. You're very fast, guys. Very fast. Very good job. Yeah. So now we have our sun and our earth both being stuck on one side of the strip. Correct? We will go ahead. Yes, Trisha?
The sun is upside down.
Oh, no worries. We can always put it back down, or you can stick it better.
And Trisha, the sun also roams around, no? बदमाश है, बोलता है मैं ऊपर से नीचे देखूंगा, नीचे से ऊपर देखूंगा, है कि नहीं?
Yeah. All right. Uh, Next, you'll take the other strips, which is there. All right. You had two strips, correct? So you'll take the other strip. All right. And on that, we're going to stick our lovely moon. Now, you again have one part of it which has a dot. So you will not stick it at the dot, but right after the dot, just after the logo, next to the logo, is where you will place your moon. Is that correct? Trisha, this time I'll take care that it's facing straight.
And thank you for pointing it out, Trisha.
Welcome.
Yeah. So you can just place it right next to the logo, just opposite your dot. Go ahead and do it. There we have our moon strip ready. Now we have a little bit of extra paper here, correct? So what we're going to do is for us, we're just going to fold it behind, all right? So that it remains strong. If you want, you can stick it later. If you want, you can just keep it folded. That's fine. All right. So now we have our moon, which is right there. Everyone with me till now? Show me a thumbs up. Perfect. All right. Now we're going to do something which is the big twist. All right. How do we connect both of them together? Right. So, what we're going to do is we're going to keep both these dots on top of each other. Before that, what we'll do is if you have a pencil or a pen, or you can even use a sharp, tiny scissor that I have here, right? And just poke a hole right in the middle of that dot. All right. There you go. Right. You can see I've just poked a hole. Yeah, you'll do that for both your strips. You have been given dots. For those who didn't have the printed strips, right next to Earth is one dot. All right. And opposite to your moon is the opposite side to your moon is the other dot. All right. So both the strips make a nice little poke, right? All right. Do we all have these holes ready? Yes. So we can put the holes one on top of each other, right? And what we're going to do is when you have cut out your strips, I'm sure you had some sort of a waste scrap paper, right? If you want, you can use that strip. Or we had also given you another small strip which was printed out and written, roll this strip for your pin, right? So you can either use that or you can use any other small little scrap that was cut out, right, from your um, sheet. All right. Just take a small little piece of strip. All right. And what you're going to do is you're going to roll it like a small little pin, very, very thin. All right. Make it very, very thin. You can see how I'm making it very, very small, right? So keep on rolling it, right? Roll it, roll it, roll
The
it.
size that fits the hole that you have made. Not too
Correct.
thick, otherwise it will tear the paper.
Yeah. And towards the end, because we want this to stay in place, what we'll do is we'll just put one little small drop of Fevicol, all right, or glue so that it sticks together. All right. Is that good? Just put one small dot so that it stays in place and then close your pin. Is everyone with me? Thank you, Lakshmi Priya. Trisha still needs some time for that rolling. No worries. I'll give you some more time. Does everyone have your pin ready? Very good.
All thumbs
Now
up.
is a perfect. Now what we are going to do is we are going to try and fit our pin inside a hole, right? If you feel that the hole is too small, you can poke it slightly more so that it can accommodate. But make sure it's not too big hole so that it tears apart. Yeah. So you may want to make the hole and place the pin in the earth and the sun first, right? The strip which has the earth and the sun, right? So here you go. I have my pin inside like this with the earth and the sun. Does everyone have that ready? Has your pin gone inside like this? You can see I've kept it midway. Great. Lakshmi Priya is done. What about Trisha? What about Janisha? Trisha is also done. Great. All right. What we do next is very, very simple. We're going to take our moon strip. All right. And right where we had the hole, we're going to place it on top of that pin and put it inside. Same procedure. If you feel you need to poke a hole slightly more to adjust it, go ahead and do it. All right. And just place it inside. Perfect. So I have my eclipse model ready. Do you guys have it ready as well? Make sure that you have moon facing and earth and sun facing all towards one side. Yeah. And what you can do is this little moon, which is going around, you can go ahead and shift its position. So if it comes this side, it's going to be coming in the middle of Earth and the sun. That's when our solar eclipse occurs, right? When the moon is blocking the sun for the Earth, correct? And then when you take it back this side out, you can see that it's in one line where where you have the Earth's shadow, which will be coming on top of the moon. Do you have that? Yes. Has everyone made their models?
Ma'am,
Come
can
on,
you repeat that
let's see the
process?
lunar. Come again, Lakshmi.
Sorry?
Ma'am, can you repeat that process, the
Can you
moon
repeat the
one?
process?
Yes, we will repeat the process. All
Thank
right.
you.
From where do you want me to repeat, Lakshmi? Do you want
Ma'am,
me to tell
the
you
rotate one
last?
of moon.
Rotate one. Okay. So you have your moon piece here, right? Just hold your strip right between the earth and the sun. All right. And the other one you have it here. Because it's in the pin, you can see that it can move up and down, right? So you can go ahead and place it from here, which is in the straight line. You can take it and place it here, where it comes in between the earth and the sun. And then again, we'll circle it back and take it behind. Is that clear now, Lakshmi?
Yes, ma'am.
Perfect. Perfect.
Thank you, ma'am.
Can you show us all your eclipse models? It'll be lovely to see. Can we turn on the camera just for 2 minutes?
It's okay. You can just show a thumbs up if you can't turn your cameras on. Perfectly all
Yeah.
right.
If not, what you could do is later on, you can take a photograph of it and you can share it on Instagram, right? If your parents have an Instagram account, you can post it there and tag us. We've already shared the Instagram handle of the Sky Explorers in the chat box. Yeah, you can tag us and we will reshare it on our stories so everyone can see your beautiful models.
Yeah, we can put it
Oh,
again on
lovely,
Instagram.
Trisha.
But this, each one of you. Yeah,
Yes,
can we
ma'am.
give a big heart to Pooja Didi? Come on, all of us. Let's do that.
And I'm going to give you all a hard back. Yeah, for
Yes.
being such good people and
Yes.
making such a
Yes.
great model.
Wonderful. Look at those pink hearts coming there, popping up every time. It looks lovely, isn't it? The burst of those hearts. Perfect. Pooja, thank you so very much for this. I hope everyone has enjoyed it. Okay, DS, thank you so much for this heart. Yep. Right. Okay.
All right.
Arush, we would want you to, and you don't need to memorize the stuff, Arush. You must understand. I don't want any of you children to go out there and memorize it. When you do, why did we take you through this activity with your hands involved and your brains and your heart involved? Because when we do that, you don't need to memorize anything. It becomes a part of your memory automatically, because if you enjoy doing something, it never leaves you, right? So I'm so sure today also you would have loved to do this. I'm so sure you have enjoyed Professor Vij's lecture. I'm so sure you've enjoyed Pooja Didi's lovely activity, which was thought so beautifully for you. If you have enjoyed this entire session, please go on Insta, write about it. Please go on our Insta. Ask your parents to download our Instagram on their phone, so that every time in the evening your parents can give you 10 minutes on our Insta page. You can write to us, we can reply back to you, we can have a beautiful learning happening through each other. Tell your friends about our Insta page, tell them to come there on
Ma'am,
Insta page. Yes, please.
ma'am, is it the logo of your Instagram is blue?
Yes.
Yes, it's written the
Yes.
Sky Explorers. And also, you know, we are the next few days and the last few days, we've posted some amazing blogs. You must go and read these blogs. They will add to your, they will add to your knowledge. If you have doubts about the blogs, then you can always, write to us. We love to answer you back. We love to tell you, things
I
if you
followed
have
it.
doubts. Yes. Followed it? Oh, Lakshmi, that is so good. Thank you so much. All right.
Welcome, ma'am.
And yeah, if you are a crazy astronomy buff like the way we are, then you're always welcome to meet us, write to us, ask us where you want to meet us. We can guide you with regards to how you want to study, what you want to study. If in your future you want to get into astronomy, space science, astronauts, and everything else that comes within this universe. And sometime, if you want to ask us about black holes, we don't mind answering you that as well. All right. So today we'd like to say thank you all very, very, very much for your presence. I'd like to thank all the school coordinators, principals, teachers who've taken the effort to be here. I would like to also, on behalf of the Sky Explorers, thank all you beautiful teachers on a belated Teachers' Day. I'm so sure you imbibe all the values that Dr. Sarvapalli Radhakrishna had, and made his students declare this day as a Teachers' Day. So, loads of love to you, all you teachers, loads of love to all you students. Thank you for being here. We're going to see you soon with another lovely episode of Something to Talk About. Yeah. So have a lovely day. And hopefully, if you guys can manage to come to Nariman Point, please come. If you cannot, please go on your building terraces with your family. Please do not go alone. All right. Safety is very important. Not only that, you can also show your parents the lovely phenomena called the lunar eclipse and tell them that it's pure science, pure geometry. It's got nothing to do with superstitious. Make it a party, take some food up, and enjoy it. And thank you once again for my entire team here for taking all the effort so that this goes without any hiccups and any problems. And Pooja, thank you for the lovely idea of the YouTube. We enjoyed it. Thank you guys from the Sky Explorers. We are going to sign off. Thank you, everyone. And I'm going to give all